Now we shall discuss the tests for similarity. In all, there are four tests for similarity. The first test is AA test or AAA test, means angle test or angle test. Now consider these two triangles ABC and PQR. Let's say angle A is equal to angle P and angle B is equal to angle Q. Let's say this angle is 30 degrees. So this angle would also be 30 degrees. And let's say this angle is 40 degrees. So this angle would also be equal to 40 degrees. Then by the AA test, the two triangles are similar. And let's say 40 plus 30 is 70, 180 minus 70 is 110. If all the three angles were given to be equal, then we would have used the AAA test. So basically AAA test means all the three angles of one triangle are equal to the three angles of the other triangle. But if we are only given two angles, 30 and 40, in a way of 50 and 40, or 40 and 110, 40 and 110, we can still use this similarity by AA test. Now, this AA test or AAA test can be used in many places. For example, in case of a trapezium, in case of a trapezium, AA test is widely used. Let's see how. See over here, we have a trapezium ABCD, and AB is parallel to CD. Then we can say that this angle A means angle BAO. Angle BAO is equal to angle C. BCO, because they form a Z shape and therefore they are alternate angles. So this angle and this angle are equal. And we have a vertically opposite angle. Angle AOB is equal to angle COB. Angle AOB is equal to angle COB. So if we know that the two angles of this triangle and the two angles of the other triangle are equal, then the triangles are said to be similar. Then triangle AOB is said to be similar. This is similar to triangle COB. By which test? By angle test, AA test. Of course, we could have said that this angle B and this angle D are also equal, they are also alternate angles, they also form a Z shape. Then in that case, we would have written an extra step. Angle ABO is equal to angle CDO, and therefore triangle AOB is similar to angle COB by angle test. That's one the same. So remember, AA test is used in trapeziums. It is used over here in trapezium. This is a very important thing that you need to remember. Other places where there is a triangle and there is a line PQ parallel to BC, let's say. Now remember, this is also the case of BPT, basic proportionality theorem. In basic proportionality theorem, we have said that in triangle ABC, if PQ is parallel to BC, then AP upon PB is equal to AQ upon QC. But now we are going to consider that these two triangles APQ and full triangle ABC are similar. How? So here it is. Angle A is a common angle. So we can say that angle PAQ is equal to angle BAC, because it is the same angle with different names, PAQ and BAC. Or you can simply write angle A is equal to angle A. And the reason is common angle. Okay, common angle. It's not vertically opposite. And since PQ is parallel to BC, we can say that these two angles Angle P is equal to angle B because they form an F shape. So here it is F shape. This is angle P and this is angle B. They form an F shape. Like over here we had the Z shape. This angle A and this angle C form the Z shape and they were alternate. So remember F shape means corresponding angles. Over here we have corresponding angles and this is corresponding angles in terms of parallel lines. So angle A is equal to angle A and angle P is equal to angle B. Therefore, triangle APQ is similar to triangle ABC again by AAA test. And we could have extended this to AAA test if you were to say that angle Q is also equal to angle C. But there is no need for it. So this was the AA test or AAA test. Rather we use AA test. The next test is the side angle side test. Now remember, side angle side test was also there in case of congruence when the two triangles were exactly equal, congruent. But this is the test for similarity. What does this say? This says that if AB upon PQ, it's written over here, AB upon PQ is equal to BC upon QR, and the angle between them, angle B, is equal to angle Q, then the two triangles are similar by SAS test. This is side, this is angle, this is another side. So SAS test. Let's say this is 2 and this is 3 times it, which is 6. Let's say this is 3 and this is 3 times 3, which is 9. Let's say this is 15 degrees, so is this 15 degrees. We can say that AB upon PQ, I'll write it over here, AB upon PQ is equal to 2 upon 6, which is equal to 1 upon 3. And BC upon QR is also 3 upon 9, which is 1 upon 3. So you can say that AB upon PQ is equal to BC upon QR. And angle B is equal to angle Q. Therefore, triangle ABC is similar to triangle PQR by SAS test. The next test that we will discuss is the last one, side test, SSS test. In this case, there are no angles to be equal, but we have AB upon PQ is equal to BC upon QR is equal to AC upon PR. So let's say this is 2, this is the double of it, which is 4, this is let's say 1.5, and let's say this is the double of it, 3, let's say this is 1.8 and the double of that is 3.6. So we can say that AB upon PQ is equal to 2 upon 4, which turns out to be 1 upon 2. In the same way, you can say that BC upon QR is equal to 1.5 upon 3, which is 1 upon 2. And AC upon PR is 1.8 upon 3.6, which is also 1 upon 2. So you can say that therefore, AB upon PQ is equal to BC upon QR is equal to AC upon PR. And therefore, the two triangles are similar by SSS test. And you can find a lot of examples in the exercise 1.3. Now, let's take this example. Let's say there is a triangle ABQ and there's another triangle ABC, and we have been given that PQ is parallel to BC. So we can use BPD, no doubt. Those 2 upon 4 and 3 upon 6 are proportional. We can say that PQ is parallel to BC if it is not even given. We can use the converse of BPT to say that PQ is parallel to BC. But there is no real need for that. Why? Because in order to find what is PQ upon BC, this PQ upon BC, we need to find the full side AB. So this is 2, AB is 2, BB is 4, so the full side would be 6. And if AQ is 3, QC is 6, the full side would be 9. Now, let us just ignore 6 and 4. You can say that in triangle APQ, alright, over here, in triangle APQ and triangle BAC. Remember, we are not using the BPT, we are using the triangles. APQ. So, okay, if the name of the triangle is APQ, it should be, other triangle should be ABC. Because the reflection of A is A, the reflection of B is B, and the reflection of Q is C. We can say that AP upon AB, which is 2 upon 6, which is 1.3, and AQ upon QC is equal to 3 upon 9, which is again 1.3. So we can say that from above, AP upon AB is equal to AQ upon QC. AP upon AB is 1.3 and AQ upon QC is 1.3. So AP upon AB is AQ upon QC. So this AP upon the full side AB is equal to AQ upon the full side AC. And then we have a common angle. Always remember that angle A is a common angle. So we can say that angle A is equal to angle A. And therefore, triangle ABQ is similar to triangle ABC by side angle side test. So remember, this is the first side, this is the second side, and this is the angle in between them. It's SAS test. So the two triangles are similar by SAS test. And therefore, if we prove that the two triangles are similar, we'll just erase this out. If we can prove that the two triangles are similar, we can say that AB upon AB, you can see it, AP upon AB is equal to PQ upon BC is equal to AQ upon AC. So second and third letter, PQ upon BC and is equal to AQ upon BC. Let us substitute what is AP. AP is 2, AB is 6, PQ we don't know, BC we don't know. And let us put it. So 1.3. So our final answer is PQ upon BC is 1.3. And when we write this after proving the triangles similar, or when the triangles are already given to be similar, then AP upon AB is equal to PQ upon BC is equal to AQ upon AC. The reason for this would be corresponding sides of similar triangles. Always use when the triangles are already known to be similar, whether given or proved, and they are the corresponding sides of it. We also use similar triangles in shadow problems. For example, let's say there is a pole AB standing perpendicular on the ground. It has a shadow of 4 meters, let's say. And there is a tower, that's a PQ, which is also perpendicular to the ground, and it has a shadow of 28 meters at the same time of the day. So you're asked to find what is the height of the tower. You need to find the height of the tower. So we shall use the similarities of triangles. Since the time of the day is same, we can say that triangle ABC is similar to triangle PQR. This is directly given. So we can say that AB upon PQ, first two letters AB upon PQ, is equal to BC upon QR, the other two letters. And we need not write AC and PR because that is neither given nor asked. And the reason would be corresponding sides of similar triangles. They are similar triangles, it is given, and these sides are the corresponding sides. And then let us substitute. If AB is 6 and PQ is not known, and BC is 4 and QR is 28, which we can cross multiply. 6 into 28 is equal to 4 into PQ And then we can say that 6 into 28 upon 4 is equal to PQ, and 4 1 are 4, 4 7s are 28, so PQ is equal to 6 7 42 meters. One more thing that you need to note is that we use SSS test to prove triangles similar. For example, if this is given, this is 1, this is 1.5 into 2, 2, 3, and 4, we can see that 1 is the half of 2, 1.5 is half of 3, 2 is the half of 4. So you can say that AB upon PQ is equal to 1 upon 2. Then you can say that BC upon QR is 1.5 upon 3, which also turns out to be 1.2. And you can also say that AC upon PR is equal to 2 upon 4, and that is also 1.2. So you can say that, therefore, AB upon PQ, that is 1.2, should be equal to BC upon QR, which is also 1.2, is equal to AC upon PR, which is also 1.2, and therefore by side test, therefore by side test, triangle ABC is similar to triangle PQR. So this is a side test. But a very similar thing, if triangles are given to be similar, so we need not prove them that they are similar by SSS test. We use CSST for providing the reason, corresponding sides of similar triangles. So if triangle ABC is similar to triangle PQR, remember this is either given or we have just proved it. Then we can say that AB upon PQ is equal to BC upon QR is equal to AC upon PR, and the reason would be corresponding sides of similar triangles. And this is not the SSS test. In the very same manner, we can say that therefore angle A is equal to angle P. Let's say we have been told that angle A is 50 degree, find angle P. We can say that angle A is equal to angle P, and that is equal to 50 degrees. And the reason for this would be corresponding sides of, so corresponding angles of similar triangles. Let's write it properly. It's corresponding angles of similar triangles. So similar triangles is already known to us, either given or just proved, and these are the corresponding angles. These are the angles. So practice 1.3 properly and get better understanding.